In this video, we're going to consider transformations as functions. And to do this, I want you to think back to those function machines that you used in Algebra 1. You input something into the machine, performed a function upon it, and then had it spit out something that you called the output. Well, now we're doing exactly the same thing, but instead of performing a function on the input, we're performing some kind of transformation on the input. So in this first example, you can see they've got this nice little picture here of this transformation machine where they're going to perform a transformation of a dilation with scale factor 2. Now, we haven't talked about dilations so far yet this year. In fact, we're going to discuss them more in January. But you saw enough about dilations in your 8th grade math class that you should remember that a dilation with a scale factor of 2 will multiply each of the coordinates by 2. So we're inputting this triangle ABC, and under a dilation of scale factor 2, what that's going to do is it's going to take and it's going to multiply each coordinate by 2. So A prime in the output, when you multiply each coordinate by 2, ends up being 6, 12. B prime, when you multiply each of those 2's by 2, or I'm sorry, B, when you multiply each of those 2's by 2, ends up having an output of B prime of 4, 4. And lastly, an input of C with coordinates 4, 2, after a dilation with scale factor 2, will have an output of C prime at 8, 4. So again, we're taking the pre-image and considering the pre-image to be the input, and what comes out at the end, the image, is our output. All right, so let's go ahead and look at this second example. It says a transformation function machine is shown at the left. So the transformation that's being performed on whatever points that we choose to input into this machine is the transformation that'll move any point with coordinates x, y by subtracting 1 from the x value and adding 6 to the y value. So the point that we're going to input into this machine is point P with coordinates 2, -5. And it wants to know what the output is after this particular transformation has been applied. Well, our transformation says take the x value of 2 and subtract 1. So when we take the x value of 2 and subtract 1, we end up at 1. This particular transformation says take the y value and to that add 6. So when we add 6 to the -5, we end up at 1. So the output, or our P prime, our image under that particular transformation, is the point whose coordinates are 1, 1. All right, the last example is a little bit different. We've still got the same transformation machine, but in this case, now they're telling us the output. They're telling us or letting us know that the transformation that was performed was a reflection in the x-axis, but they're asking us to determine, in this case, the input. In other words, what was the pre-image that's going to land us at a point M prime with coordinates -4, 2 after a reflection in the x-axis? In order to do this, I'm going to go ahead and draw a little sketch, just because anytime I reflect over a horizontal line or a vertical line, I like to solve those types of questions by drawing my lines. So my point with coordinates -4, 2 is right there. That's point M prime. And I'm trying to figure out where that point started before he was reflected in the x-axis. So remember that the vertical axis is the y-axis, the horizontal axis is the x-axis. So in other words, the axis that was reflected over is this guy right there. So this question is asking was, where was this point before he was reflected over the x-axis? Well, he ended up 2 units above the x-axis, so he must have started out 2 units beneath the x-axis, making the coordinates of his starting point -4, -2. So the input here was point M with coordinates -4, -2. All right, like always, I want you to summarize the key ideas and important takeaways from this video, and I do want to outline a little bit about what's going on in these two apply what you've learned questions, because they're phrased just a little bit differently than I phrased them in the video. So in number 2, they give you that quadrilateral, and they're going to input that into some transformation machine. This particular transformation machine is going to rotate the quadrilateral 90 degrees counterclockwise. So in part A, they ask, what is the rule? What they're really looking for here is the specific transformation. So they want to know what kind of transformation. Is it a translation? Is it a line reflection? Is it a rotation? Which one is going to turn the quadrilateral clockwise 90 degrees? And then what will be the coordinates of the output, in other words, the image, under that specific transformation? And in number 3, again, they ask the question just a little bit differently than I would. It says a transformation function will take the line segment with endpoints A and B is an input. The function rule is going to be applied to that segment. What are the outputs of the endpoints? So in other words, they only want the outputs of the endpoints. They want to know the coordinates of A prime and B prime under that rule that's applied to the line segment. All right, folks, so that's it for this video. If you have questions or about anything I said in the video, now would be a good time to write them down. And as always, again, I do want you to take some time, think about what you've learned, put those thoughts into your own words, and write them at the top of page 23.